Hey there, future physicists. Welcome to today's Explainer, where we're going to unlock the absolute, real-life secret rules of the universe. Have you ever stopped and wondered what actually makes everything in our world move, or stop, or crash together? Well, today we're going to reveal the hidden magic behind all of it, force and motion. So get ready, because by the time we're done here, you are going to see the world completely differently.
But before we get to the rules, let me ask you a quick question. Picture this, you're standing on a bus, and the driver suddenly steps on the gas. You immediately fall backward, right? Or what about when they slam on the brakes and you go lurching forward? It almost feels like some invisible hand is just pushing you around. Well, spoiler alert, there are no ghosts on the bus. It's actually a basic rule of the universe at work. And to understand it, we've got to understand the invisible magic behind it all.
Okay, let's dive into Section 1, what is a force? Or, as we like to call it, the invisible magic.
So what is a force? Simply put, a force is an effort. It's a push or a pull that makes objects move, stop, or even change shape. Now here's a kind of wild fact for you. No one has ever actually seen, tasted, or felt a force directly. You can't just catch a force and put it in a glass jar. But we absolutely always see or feel its effects. Every single time you kick a soccer ball, yank open a really heavy door, or stretch a rubber band until it completely changes shape, you are using a force. You're using that invisible magic.
Now, the crucial point here is that forces basically come in two flavors, balanced and unbalanced. Imagine a massive game of tug-of-war. If both teams pull with the exact same strength from opposite directions, well, the rope doesn't move. Nobody wins. That is a balanced force. They literally cancel each other out, so you get zero movement. But if one team suddenly pulls just a little bit harder, bam, the forces become unbalanced, one side wins, and movement happens. The rope gets yanked across the line. Basically, the universe only lets things start moving when the forces are unbalanced.
Let's look at another example. Imagine you and a friend are trying to push a giant, super heavy box across the room. At first, you push with a small force, but the box doesn't budge. Why? Because the rough floor is incredibly sneaky. It's actually pushing back against you with something called a friction force. Friction is just a force that pops up between two surfaces rubbing together, and it pushes in the exact opposite direction of you. So, to get that box sliding, you have to push harder and harder until your pushing force is finally bigger than the friction force. Once those forces are unbalanced, whoosh, the box starts moving.
All right, now that we know what a force is, let's reveal Rule 1, the lazy rule, which scientists officially call Newton's first law. The fancy science word for this rule is inertia. And inertia is, well, it's basically an object's built-in laziness. It's an object's stubborn desire to keep doing exactly what it is already doing. For example, if a football is sitting completely still on the grass, it wants to stay still forever until an unbalanced force, like your foot, comes along and kicks it. On the flip side, if a skateboard is rolling down a hill, it actually wants to keep rolling in a straight line forever until a force, like a wall or friction, stops it. Objects are just incredibly lazy. They resist any change to their plans. And hey, that's exactly why you fall backward on that bus we talked about earlier. Your lazy body just wanted to stay right where it was.
And you know, this completely explains another very cool everyday mystery. Why do leaves fall off a tree if you shake the branch really, really hard? Think about it. The leaves are just resting peacefully up there. Because of their inertia, their laziness, they want to stay exactly where they are, floating in the air. So when you forcefully yank and shake the branch away from them, those lazy leaves try to stay put, the force overcomes the little stem holding them, they snap right off, and gravity pulls them straight down. That is the lazy rule in action.
Moving right along to Rule 2, the heavy and fast rule, officially known as Newton's second law.
This one is all about how heavy an object is and how fast it's going. Imagine you're playing a game, right? Getting hit by a light, bouncy little table tennis ball really doesn't hurt at all. It just gently bounces off your shirt. But getting hit by a heavy, super fast-moving cricket ball or baseball, ouch, that is definitely going to leave a mark. Why is there such a huge difference? It's because of something called momentum. The impact an object has depends on two very important things: how heavy it is, which is its mass, and how fast it's moving, its velocity.
And this brilliantly illustrates the most famous cheat code in all of science, F equals ma. Force equals mass times acceleration. Honestly, don't let the math scare you. This just means that if you want to speed up a really heavy object, say a real car instead of a tiny toy car, you're going to need a way bigger push, a much larger force. It is just a beautifully simple little math rule that literally runs the whole universe.
Okay, let's see how this all builds into our final secret. Rule 3, the tag team rule, or Newton's third law of motion. Sir Isaac Newton, the absolute genius who figured all this stuff out, famously said, "For every action, there is an equal and opposite reaction." I really want you to let the wonder of that sink in for a second. In our universe, forces absolutely refuse to work alone. They never do. They always act in pairs on two different bodies, just like a tag team working in exact opposites. So if you push something, it pushes you right back with the exact same amount of effort.
The crazy part is, you are actually using this tag team rule every single day without even realizing it. Just think about these everyday actions. When you're walking down the street, your foot pushes the ground backward. That is the action force. And the ground? It reacts by pushing you forward with a reaction force. When you jump off a diving board at the pool, you push the board down and the board brilliantly launches you up into the air. And how do birds fly? Their wings push the air down and the air pushes the bird straight up. Action and reaction. It is literally happening everywhere, all the time.
So there you have it, my fellow future physicists. We've got the invisible magic of forces, the lazy rule of inertia, the heavy and fast rule of F equals ma, and the tag team rule of action and reaction. These are the hidden rules governing every single movement around you. So, I have a challenge for you. Which of the universe's secret rules are you going to test out in your backyard today? Go outside, kick a ball, jump in the air, and see this magic for yourself. And actually, here's one last thought to completely blow your mind. If every single action has an equal and opposite reaction, what exactly happens to the Earth when you jump off of it? Thanks so much for joining me on this explainer, and keep exploring.